we subtract complex numbers in the same way that we subtract a binomial minus a binomial, like as if I were a variable. All right, first let's open up the parentheses. So the first set of parentheses has nothing in front of it, so we can just drop those. The second set has this minus sign in front, so we're going to open up parentheses multiplying through by the negative. So here we have negative 3, and here we have negative 4i, and that turns into plus 4i. And now we just add the like terms. So we'll add a 7 and a minus 3 is 4, and a 5i and a 4i, that's 9i. In number 2, we're multiplying minus 2i times 4 minus 5i. We're going to use the distributive law, multiply through. First times 4, and then times minus 5i. So first, 4 times minus 2i, that's negative 8i. And now we're multiplying negative 2i times negative 5i, so we have a plus 10. And I times I is I squared. Now remember, I squared, that's minus 1. So that would be minus 8i, negative 10. All right, in number 3, we're multiplying two complex numbers, and we're going to use the order of FOIL for our multiplication. So we do first times first, and that's 15, 5 times 3. And then we'll multiply the outer term, so that's minus 20i. And then the inner terms, so that's plus 6i. We add these and we get negative 14i. All right, and now for last times last, we have 2 times minus 4, so that's negative 8, and there we have that I squared. And remember that I squared is negative 1. All right, so let's rewrite this. We have 15 minus 14i, and here we have negative 8 times negative 1, so that's a plus 8. So now let's add the 15 and the 8, so that would be 23 minus 14i. In number 4, we're just looking at some notation. All right, so this says if the letter z, the variable z, is equal to 7 minus 2i, then what is z bar? So let's remember that that bar notation means take the complex conjugate. So z bar would be, in this case, 7 plus 2i. All right, so again, bar on top means take the complex conjugate. All right, if this is negative, the complex conjugate has a plus. In number 5, we're multiplying two complex numbers, and notice that they are complex conjugates, 5 plus 3i, 5 minus 3i. So let's remember our little formula that we have for multiplying complex conjugates. So that would be a plus bi times a minus bi is equal to a squared plus b squared. And we can see that if we FOIL this out. Look at the a squared comes from here, a times a. Notice that the middle term coming from outer and inner drops out. They're of opposite signs. Here we have minus abi, and here we have plus abi, so those drop out. And this b squared comes from last times last. That would be minus b squared I squared. And I squared is negative 1, so we get the plus b squared. All right, so we're going to use this formula in number 5. Our a is 5 and our b is 3. So here we just have 5 squared plus 3 squared, or 25 plus 9, which is 34. When we multiply conjugates, we always end up with a real number, something without I. All right. In number 6, we are looking for the reciprocal of 2 plus 7i, or you can think of this as dividing 1 divided by 2 plus 7i. And the way we divide complex numbers is we're going to multiply top and bottom by the conjugate of the denominator. All right, so in this case, the denominator is 2 plus 7i. So we're just going to multiply top and bottom by 2 minus 7i, the conjugate. All right, so in the numerator here we have 2 minus 7i. In the denominator we're using that a squared plus b squared formula, so we have 2 squared plus 7 squared. So that's 2 minus 7i. And here we have 4 plus 49. Or 2 plus, sorry, that's minus. 2 minus 7i divided by 53. All right, in number 7, we're doing a division of complex numbers. So again, we're going to use the complex conjugate. I'm just going to rewrite this. And the complex conjugate of the denominator is 2 plus 3i. So we multiply top and bottom. The denominator multiplication, we use the formula a squared plus b squared, so that would be 2 squared plus 3 squared. And the numerator requires a FOIL multiplication. So let's do that. 3 times 2 is 6. And then outer 3 times 3i, that's plus 9i. And then the inner 4 times 2i, that's a plus 8i. And then last, here we have a 12. And then I squared is minus 1, so that's negative 12. All right, let's just simplify this a little bit. Here we have 4 plus 9, so that would be 13 in the denominator. And in the numerator, we'll do 6 minus 12, that's negative 6. And add 9i plus 8i, so we have 17i. Okay, so finally in number 8, we're just looking at 1 over minus 5i. And basically we're going to do the same trick, multiply top and bottom by the conjugate. So here, the conjugate of minus 5i would be plus 5i. All right, you could think of this as 0 minus 5i. So the conjugate is 0 plus 5i, or just 5i. All right, in the denominator, we have a negative 25i squared. And in the numerator, we have 5i. I squared is minus 1. So we have a positive 25 here. And let's just reduce this, divide top and bottom by 5. So we have I in the numerator over 5.